So what does the question say here? It says that find a point on the x-axis, which is equidistant from the point 2 comma minus 5 and minus 2 comma 9. Since we have to take the point, let that point be C. Since that point is on the x-axis, which would mean its y coordinate is going to be 0. So the form for that particular point will be x comma 0. So we have to find a point x comma 0 such that AC is equal to BC. This is what we have to find out. So for the given figure, what do we get? What is AC going to be equal to? AC is going to be equal to x minus 2 whole square plus 0 minus 5 whole square. Right? 0 minus 5, since it is minus 5 here. So you get root over x minus 2 whole square plus 5 square, which is 25. Similarly, what is BC? BC is going to be equal to x minus 2 whole square plus 0 minus 9 whole square. And this would be equal to x plus 2 whole square plus 81. Minus 9 square is also going to be 81. Given that, according to question, what is given? AC is equal to BC. Since the point C is equidistant from the points A and C, so AC is equal to BC. Therefore, you have root over x minus 2 whole square plus 25 equal to root over x plus 2 whole square plus 81. You square on both sides, which is perfectly fine to do. So you get x minus 2 whole square plus 25 is equal to x plus 2 whole square plus 81. You take the x factor this side and the 25 to the other side, and what do you get? X minus 2 whole square minus x plus 2 whole square is equal to 81 minus 25. What does 81 minus 25 mean? It's 50 and 6, 56. And what do you get here? It's a square minus b square. So you have a plus b into a minus b is equal to 56. 2 and 2 cancel out here. So you have 2x. Here x and x could cancel out. So you have minus 4 here, which is equal to 56. So you have x equal to, you have minus 8 here. So you have x equal to 56 by minus 8, which is minus 7. So you have one point on the x-axis which is equidistant from the two given points, and that point is going to be minus 7, 0. There are going to be 2 points in the plane which are going to be equidistant from AB, one this side and one this side. But it is clearly given that the line lies on the x-axis, the point lies on the x-axis. So there is a constraint to it. Hence, we get just one value of x, which is equal to minus 7 comma 0 here. You don't get two values of x through a quadratic equation. So this is how you solve this problem. It's given here that the 2 points are equidistant from a third point. That third point lies on the x-axis. So its y coordinate is going to be 0. You find out the distance AC using distance formula. You find out the distance BC using distance formula. Given according to question, AC is equal to BC. And then you simplify it and you obtain the value of x. In this case, it comes out to be minus 7. So the point that you would be getting is minus 7 comma 0. Now in this next question, we have to prove that the distance of the point a cos alpha comma a sin alpha from the origin is independent of alpha. So you have the origin and you have the point A, which is a cos alpha comma a sin alpha. And what do we have to do? We have to prove that the distance of this point A from the origin, that is OA, is independent of alpha. So you have two factors here. You have A and you have alpha. As alpha changes, the position of point A is going to change. As the value of A changes, the position of value of the point A would change. So it says that irrespective of what the value of alpha is, the distance OA is always going to be same. It's not going to change if only the alpha is changing and A is constant. How do we prove that? Since it is said that we have to prove that OA is independent of alpha, we have to first find what OA is. OA is equal to root over this difference of their x coordinate whole square plus difference of y coordinates and the square. And what would this be equal to? This will be equal to a cos alpha whole square plus a sin alpha whole square. What is this? It's a square cos square alpha. Cos alpha square is written as cos square alpha, and this will be a square sin square alpha. A square is going to be constant, so common would be cos square alpha plus sin square alpha. And what is cos square alpha plus sin square alpha? It is always equal to 1. Hence, what do you get? You get root over a square, which is equal to mod a. Why have I written mod a again? A could be positive, A could be negative. Hence, I have put a mod sign over here. It doesn't matter. It doesn't affect the result. It actually makes it correct, because if suppose A is minus 4, then what will be root over a square? Root over a square will be root over minus 4 square, which is root over 16, right? So, root over 16, what would we write it as? Would it be 4 or would it be minus 4? What will it be? It could be any of those two, right? For minus 4 square also you will be getting 16 here. So, the square root can be either 4 or minus 4. But since OA is the distance, hence we cannot have minus 4 as the value of a square root. So, we put a mod sign. So, whatever comes, you will end up getting the number without the sign. Hence, I have put root over a square is equal to mod a. And so, we get the value of OA as independent of alpha. There is no alpha factor here. So, whatever the value of alpha is, the value of OA is not going to change. If alpha is 0, if alpha is 60 degrees, if alpha is 45 degrees, it doesn't matter on the result, because there is no alpha in the distance. There is no alpha in the value of OA. Hence, whatever its value is, it is independent of alpha.